Hello students, this is Vitthal Anwat and today we are going to discuss upon our subject geography of soil, and in that we will be cover the soil chemistry chapter number 4. The topic is types of soil colloids. The soil colloids. What is soil colloids? The colloidal state refers to two-phase system in which one material in a very finely divided state is dispersed through second phase. Means soil colloids is nothing else, it's a colloidal state of the anything. Colloids means the particles which are made from different types of the materials. Okay, like as soil is a one colloids, we can get example of one small particle of the clay, and this is a clay is a colloid of the soil, and it's made from there are many several factors which is included in there, many nutrients, then organic matters, then water. These are the with the help of this content such things has been prepared. After that we can say that this is a soil colloid. There are many examples related with the soil colloids, like as a solid in a liquid. It's a example of clay in water, dispersion of clay in the water. Then another examples of the soil colloids is liquid in a gas. We can get the example of fog or the clouds in atmosphere. Then the clay fractions of the soil contains particle less than 0.002 millimeter in the size. Particles less than 0.01 millimeter size possess colloidal properties and are known as the soil colloids. The general properties of the soil colloids. What are the general properties of soil colloids? They are the following. Like as the first is the size. The most important common property in the organic and organic colloids is they are extremely small in the size, and they are too small to be seen with an ordinary light microscope. Means the size of the colloid is very tiny, and this is the general property of the soil, and only with an electron microscope they can be seen. Most are smaller than 2 micrometer in the diameter. This is a major characteristics or the property of the soil colloid. The second one important property of the soil is surface area. Because of their small size, the all soil colloids expose a large external surface per unit mass. The external surface area of 1 gram of the colloidal clay is at least 1000 times that of 1 gram of the coarse sand. Means after the size, the surface area also play important role into the so any kinds of the soil colloids. Some colloids, especially certain silicate clays, have the extensive internal surface as well. This internal surface occur between the plates like crystal unit. They that make each particle and often greatly exceed to the external surface area. The third important properties of the soil property is the surface charge. Soil colloidal surface, both external and internal, characteristically carry negative or the positive charge. As we know, the electrons and the protons both are the one is the electron, and another electron is a negatively charged, and proton is a positively charged. For most of the colloids are the electronegative charge predominant. Soil colloids, both organic and inorganic, when suspended in the water carry a negative electric charge. Ionizable hydrogen ions and isomorphism substitutions. These are some chemical properties of we can say here these are the which are the negatively and positively charged. Means ionizable hydrogen ions means the small, we can get the example of small particles of the water. Okay. Then fourth important property of the soil is the absorption of cations. As the soil collides the process negative charge, they attract the ions of the opposite charge. This is a simple formula we learn into the chemistry. To the colloid surface, they attract the hundreds of positively charged ions or the cations such as hydrogen, okay, then aluminium, then calcium, and another magnesium. These are give rise to an ionic double layer. Then another one property of this colloids is absorption of water. In addition to this absorb the cations, a large number of water molecules are associated with the soil colloidal particles. Some are attracted to the absorb the cation, each of which is hydrates. Others are held in the internal surfaces of the colloidal particles. These water molecules play critical roles into determining both the physical and chemical properties of the soil. Then cohesion. Cohesion is the phenomenon of sticking the together of colloidal particles that are the similar nature. So the cohesion is a phenomenon of the sticking, means they stick to with each other, like as water stick to the clay particles, or the we can get the example like as organic matter is dissolved into the soil, that time it's a mixed or it's a stick. Actually organic matter is stick to the soil, means this is a cohesion process. And cohesion indicates that the tendency of clay particles to stick together, this tendency is primarily due to the attraction of the substance. Then adhesion is referred to the phenomena of colloidal particles sticking to other substance. In this sticking of the colloidal one material to the surface of the body or substance with the which is come in correct contact of the its. Then the swelling and shrinkage. Some clay such as soil colloids such as the smectites well when we and shrink when they get dry. After the prolonged dry spell, soil high in the smectites, like as vertisols often are the crises crossed by the deep crack, which is the first allow rain to the penetrate rapidly. Then dispersion and the flocculation. As long as the colloidal particles remain charged, they repel each other and the suspension remain stable. Then Brownian moments, when the suspensions of the colloidal particles is examined under a microscope, the particle seems to oscillate. Oscillation means just zigzag behavior of the any particles. I mean they are not stable. They move one side to another one. That time we can say it's a oscillation or the Brownian moment. Then non-permeability is a major property of the soil colloids. The colloids, as opposed to the crystalloids, are unable to pass through a semi-permeable members or the membranes. And we can say here that the sometimes the colloids are the opposed to the crystalloids are the unable to pass through the same types of the permeable membrane. Permeable membrane means they are the their particle size is equally same. That time they do not easily permeable to each other. These are the some properties of the soil colloids. Thank you very much.